Okay, let's get started. So I'd like to welcome you guys to Web8 Solutions webinar series. Today's topic is querying transactional or relational and analytical databases using SQL, MDX, and DAX queries. So first of all, we will discuss what transactional or relational databases are, and then we'll also talk about analytical databases, and then we'll see why we have so many different query languages such as SQL, MDX, DAX, and when exactly we should use what language and so on. So obviously it's uh, just a 1 hour sort of session, so we'll not be able to cover everything end to end, but you'll get a high level picture of what exactly these things are, when and why we should use these things and so on. Okay, so today's agenda is, first of all, we will talk about various types of databases, then we will talk about various query languages, and then we will focus on relational databases or transactional databases. We will look at the select statement syntax, and then we will talk about multidimensional databases, and we will have a look at MDX and DAX queries. Okay, so first of all, let's start off with different types of databases. So usually we have a lot of different types of databases, but here I've kept it a bit simple by just focusing on some of the most commonly utilized databases, like relational analytical databases. So even when we talk about analytical, there are various subtypes available, but here in this session, we will focus on multidimensional and tabular analytical databases. They're also known as tabular data model sort of databases. But usually we have even more types of databases available, such as graph-based databases, like Gremlin is one of the very commonly used examples. We have document-based, like MongoDB, etc., and so on. So our main focus will be to focus on relational and analytical databases in this particular session. But before that, let me give you a quick overview of these options as well, like graph and document-based. So database, we need to create some database so that we can store our data. So although you can keep your data in CSV, Excel, spreadsheet sort of formats as well and so on. But typically when we talk about enterprise sort of data format or some repository, usually we have to rely on some more enterprise type of database engine. So for that, if you, let's say, use graph, so or graph-based database. So graph-based database basically means that you want to have sort of a hierarchical structure or nodes that connect to each other. So in case of graph, you'll basically have some data or a node that will represent some data that will be connected to some other node, and that can be connected to some other node and so on. So basically, you can have a hierarchical or a sort of a node-based structure where each node can be connected to some other node and so on. A very common example of where you will want to use this graph sort of database would be, say you want to store maps sort of data. So if you have, let's say, geospatial sort of data, like latitude, longitude, stuff like that, and so on. So think of, let's say, Google Maps or Bing Maps and so on. So if you have to, let's say, represent various points of interest, you have to create all the possible routes, the roads, etc., and stuff like that, and so on. Although you can choose to use a regular relational or table-based structure for that, but usually graph-based structure will be more suitable in that case. So basically, you'll be able to know what locations are connected to each other, what routes are available, etc., and so on. So that is one of the examples. Likewise, another example would be that of, say, if you talk about social networking sort of sites. For example, let's say Facebook. So Facebook usually keeps track of who knows who. So if this is one of the social networking, or let's say Facebook users, who does this person know? And what's the relationship with the other person, etc., and so on. So even in that case, when you have sort of a recursive sort of patterns, or you have tree sort of structure or hierarchical sort of structure or node sort of structure where nodes are interconnected, typically graph-based database will be more suitable. So it's a very specialized type of database. And you can use Gremlin. Gremlin is a very commonly used graph-based option available. Likewise, we have another type of database listed here. It's not the main scope of this course, or sorry, this session. The main focus will be on relational and analytical that I'll talk about in detail in just a bit. But before that, let me just quickly go over these as well. So we have another type of database that's usually known as document-based database, or it's also very commonly known as NoSQL database, NoSQL. So NoSQL or NoSQL stands for not only SQL. So not only SQL typically means you're not going to store data in relational format like the way we usually have in our typical databases. Instead, you're going to store the data in the form of various objects or various documents. So for example, if we have JSON sort of data, that stands for JavaScript Object Notation. It's a very commonly used format these days, especially when we have to work with web services or REST APIs, etc. and so on. We quite often use this JSON sort of data format. Or even if we have XML sort of data format, even there you can utilize this document-based approach if you want, but more commonly we use JSON. Otherwise, you can also choose to use YAML as well. That's yet another data interchange format. So basically, when you store your data in the form of documents, in the form of objects, so each record will be represented by a JSON file. So that is where we get to use this concept. And very common examples are that of MongoDB. You can use Cosmos DB, you can use DynamoDB. So there are various options that you can use to implement this document-based sort of database. Cosmos DB is actually a huge area. It's actually a collection of various APIs, like it can let you connect to your document-based data, it can let you connect to your graph-based data, even to your SQL sort of data, and you get to use the same select statement that we typically use when we have any relational database and so on. So basically, we have various types of databases. These are more suitable, especially if we talk about Cosmos DB and DynamoDB. They are more suitable when you have cloud-based scenario, like you have Microsoft Azure, and you're expecting literally millions of records and even millions of users who will be accessing the data at the same time. So for that purpose, we need some specialized database so that we should not have any performance sort of issues and so on. So in short, just know that there are various types of databases. And our main focus will be on relational and analytical in this session. And I'll talk about these in detail in just a bit. And just like we have different types of databases, likewise, we have different types of query languages. So when you have to query your data, you have to use some appropriate query language. So for example, we have Transact SQL, or we can call it structured query language. We have MDX, multidimensional expressions, data analysis expressions. There's a DMX as well. So we have quite a few options available. So keeping this in mind, later on, I'll discuss when exactly we should use SQL, MDX, and DAX. For now, just know that these are all specialized query languages. They are meant for certain types of databases. So for example, DMX is not the main scope of this session. So I'll just give you a quick overview of it right away. So in advanced scenarios, when you want to, let's say, analyze your data and you want to perform data mining, you want to go through tons and tons of data, and you want to get some meaningful sort of recommendations, like or suggestions, or let's say some profiling, data profiling. Like let's say, usually what are the chances that the customer will be, let's say, female, and the customer will have so many number of kids, the customer will have certain salary, etc. and so on, and the customer will purchase a certain product in the next month. So basically, you can get some interesting patterns like these. For that, we get to use this data mining that allows us to utilize predictive analysis, etc. and so on. So it's a data mining sort of query language. So this is not the main scope of the session. That's why I've just given you a quick overview of it right away. The main scope of the session is to focus on SQL, MDX, and DAX. Okay, so we have explored various types of databases, and we have discussed the fact that we have various types of query languages. Now let's focus on relational databases. So relational databases, they are the most commonly used databases, like SQL Server, Oracle, MySQL, DB2. These are typically relational databases. And these are also known as OLTP databases. OLTP stands for Online Transaction Processing Database. So the main emphasis here is on this letter T, transaction processing databases. So these are optimized for transactions. So transactions basically means insert, update, delete. So you're mostly going to focus on these operations. Sure, you'll want to execute the select statement as well to retrieve the data. But typically, relational databases are optimized for insert, update, delete sort of operations. Later on, we will talk about analytical databases, and you will notice that they are optimized for the select operation. So in relational databases, we create tables where we store our actual data. So we will have rows and columns sort of structure. We can have multiple tables. So each table can contain a certain entity's data. Like you can have a table for customers, a table for employees, a table for product, etc., and so on. And usually we use certain data types to make sure that each column stores the appropriate data. Like we can store numeric values, we can store a string. So for example, we can store a single letter, or we can store multiple letters or text basically, or sort of a string basically. For that, we could use varchar. Or you can also choose to store multilingual data by using something called Unicode concept. So N basically means these are Unicode typed data types, and we can store multilingual sort of data and so on. We also have some advanced data types as well. There are actually quite a few of them, but a quick summary of some of them, it's listed here. We have hierarchy. So hierarchy allows us to create a single column that can store multiple things, such as the level. So say you want to have a product category sort of table, and each category will belong to a certain subcategory. And that subcategory can belong to yet another subcategory. So you can have a very deeply nested sort of structure. Like you can have some electronic device. So that will be one of the categories. You can have, let's say, entertainment-based electronic devices. Then under entertainment, you could have, let's say, cellular-based electronic devices, et cetera, and so on. So you can have basically multiple categories, subcategories, subcategories, et cetera, and so on. So when you have a very deeply nested sort of structure, for that purpose, we can use this data type called hierarchy. So in a single cell, in a single field, or a cell of a record, we can store multiple things. So, so it would be something like this, basically. So you'll have, let's say, the value for level 1, the value for level 2, the value for level 3, the, level 4, et cetera, and so on. So this way you can specify exactly what subcategory a specific subcategory belongs to, and what category that particular subcategory belongs to, and so on. So basically sort of a nested or recursive sort of structure. So hierarchy data type is very useful for that. So usually we cover all these data types, the advanced ones as well, in our full-blown courses that we usually offer. At the end of the session, I'll point out some of the course numbers. Likewise, we can also store XML data in a single cell. And then we can use XPath query to query that. We can use even a JSON typed cell as or field as well to store JSON sort of data and so on. So basically we can create multiple tables, and each table can have multiple columns, and we can store different type of data and so on. And typically relational databases or OLTP databases, they are normalized. So normalized basically means we have to make sure that we implement various normal forms. And although there are 5 normal forms overall, some people include more as well, but typically we just focus on the first 3 normal forms. Like it's recommended to create a primary key in each and every table. That's usually the first step. Then the second step is to make sure that you store one table per entity, or one entity per table. Make sure that each entity is or each table is a small table. Like rather than storing 10,000 columns for to represent everything that you need to focus on at your organization level, we should split it into multiple small tables. So make sure that you have multiple small tables. And then very importantly, you need to make sure that if you do create multiple small tables, like say you have a table called product, you have a table called order, you have a table called order details. So we have split your data into multiple small tables. So you'll have to make sure you do link these tables together. So you'll have to sort of virtually combine these tables so you can later on create your reports and so on. So that is where we basically focus on this relationship concept. It's out of the scope of this session because of the lack of time to focus on all the possible details. But typically we have these relationship types, like we have one-to-one. A very common example of one-to-one would be, say you have to store employee information. So each employee will have certain columns or certain fields, like employee name, first name, last name, middle name, gender, marital status, date of birth, login information, password, home address, billing address, shipping address, etc. and so on. So rather than creating a single table, you'll want to split it into multiple small tables. Like if you have to store login information, like the username and the password, it could be stored in a different table. If you have to store employee personal information, like the first name, last name, middle name, etc. and so on, it can be stored in a separate table. So this way you can easily utilize certain tables or certain columns with ease rather than focusing on the whole huge table. So one-to-one is a very useful technique when you have to split a single entity into multiple small tables, so you can organize certain columns together and so on. So likewise, we have some more advanced relationships as well, like one-to-many or many-to-one. For example, you can have, let's say, customer table, and you can have, let's say, product table. So each customer can purchase multiple products. So when you create, let's say, your orders table, see, so the same customer can place multiple orders, and the order can contain multiple products. So basically, you'll end up having a one-to-many relationship in that case, or you can call it many-to-one as well and so on. We also have many-to-many relationship. In fact, this is actually a many-to-many example, but just to make it a bit simpler, I've explained in terms of one-to-many, but this is actually a many-to-many relationship. And usually we have to be very careful about the keys. Like typically when we create the one-to-many or many-to-many sort of relationship, we do focus on the primary key for sure. And we also focus on something else as well called a foreign key. So a foreign key will basically let you link two tables together and so on. So that's where we use various other concepts such as referential integrity and cascade delete, cascade update, etc. and so on, sort of terms as well. And we can also have self-relationship, where a table can have a relationship with itself. It's not very common, but in case if you're choosing to store, let's say, employee information, and who's the manager of the employee? So technically, every manager is also an employee as well. So rather than creating two separate tables, one for employee and one for manager, and then try to link them together and so on, you can choose to create a single table, and you can say that every employee can potentially be a manager, and you can find a relationship with some other employee and find out the hierarchy, like who's the manager of what employee, etc. and so on. So basically, we have various types of relationships, and that's usually part of something called normalization. So in short, relational databases are typically normalized. They are split into multiple small tables. And usually we do that to reduce the overhead on the databases so that we should not have too many duplicates. And we should also improve the performance when it comes to updating our record or any number of records. So when you have to update your records, or when you have to reduce the redundancy or the duplicate values, we usually get to normalize the databases. And how do we query the relational databases? So for that, we get to use SQL language. Some people call it SQL, some call it SQL, although we can choose to use either of these pronunciations, but we should be aware of this thing that it's not usually just a matter of pronunciation. So SQL, back in the day, it used to be the original name of SQL. Like in 1970s, it was called SQL. So it used to stand for Structured English Query Language. We used to have this word, English. But later on, they learned that no, SQL is already sort of copyrighted and they're not allowed to use it. So they had to change it. So they ended up changing it to SQL. So formally, we should call it SQL, but informally, we can still call it SQL. But ideally, it should be just called or pronounced it as SQL. SQL does have various versions like SQL 89, SQL or SQL 92, etc., and so on. And each version introduced certain keywords, etc., and so on. So those guys who are already familiar with SQL, they must have seen keywords like inner join, outer join, left join, right join, full join, etc., and so on. So these weren't initially available. So in SQL 89, we never had these at all. So whenever we had to perform join operations and so on, we had to rely on the standard where clause. So we had to perform a cross join. We had to multiply the records, and then we had to use a where clause to filter out the records and so on. Whereas in SQL 92, eventually we ended up having these keywords like inner join, outer join, left join, right join, full join, on keyword, etc., and so on. So know that there are various versions available. Obviously, these days we prefer using the latest version. And every vendor offers a different flavor of SQL. So for example, Microsoft offers something called Transact SQL. Oracle offers procedural language SQL, and so on and so forth. So overall, they are very much identical, but every vendor offers some additional functions. Like in SQL, we have a function called convert, as well as cast. Whenever you have to perform type casting or convert one data type to another, we have two options available, convert and cast. But cast is the only standard function that's available across all the database engines. Convert is a Microsoft SQL Server specific technique. It definitely has lots of benefits, like if you have to format your date and time, you want to use certain MMDDYY sort of format and so on. It makes it very easy. So convert does have lots of benefits, but just know that it's Microsoft SQL Server specific function. It's not available in Oracle, etc., and so on. And overall, when you have to use the select statement to perform your queries, you have two options or two main options. We can choose to use just the select keyword, or we can choose to use with select. So let me give you a quick overview of these before I show you a couple of demos here. So select statement, definitely it does have lots of additional keywords. So it does always start off with the keyword select. And after that, it can have various other keywords, like we can have with. I'll talk about with later on in the, on the very next slide. We can use order by, we can use union, all, etc., and so on. We can use into if you have to import data, you want to perform an insert operation. For that, we can choose to use this into, or even if you're not importing any data into your sort of, let's say, your actual physical table, you can still choose to create a temporary table and import it into that temp table for temporary processing of your whatever operations you have and so on. We have from keyword where. So basically, we have quite a few keywords here. To make more sense of it, let me show you a quick or before I show you the demo. So typically, we get to use select statement like this. So we have select. We can choose to use distinct keyword if you want to retrieve just the distinct record or records. We can specify whether we want to get top 10 or top 100 sort of records and so on. From what table you want to get it? Do you want to join it with other tables or not? If yes, what's the criteria? For that, we get to use on keyword. Then we have where, group by, having, order by, and so on. So in the full-blown course, we do talk about all these in detail. We talk about what keywords are optional, etc., and so on. Like generally speaking, everything is optional except for select and from. But the rest of them, we do usually utilize them in the same sequence whenever we have a specific business requirement and so on. So if this is your full-blown select sort of syntax, the way SQL Server or any other database engine will execute your select statement will be in this sequence. So the execution sequence is different than the one that you use to write your select statement. So execution sequence wise, it always loads from first, then on, then outer if you have used it, then where, group by, having, select, etc., and so on. So those guys who have used select statement, they might be familiar with something called aliases. You can assign aliases to your columns. So if you have column aliases, you cannot use those column aliases in these clauses because column aliases are assigned as part of the select portion of your overall statement. So these key clauses will not support the aliases. So that's where we get to use some more advanced concepts such as user-defined functions, etc., and so on. And let me give you a quick overview of the select statement here. Let me connect to my SQL Server here, create a simple query here. Let me use this AdventureWorks as the sample database. And I already have the query here, just so we can save a bit of time. So basically here I have utilized pretty much all the important clauses like select. We have used a bunch of functions, etc., and so on. We have this from clause where we are specifying the inner join operation. We have where, group by, having, order by, etc., and so on. So basically it will list those employees who have taken vacation hours between, or sort of time off basically, between 40 and 50 hours. So it's only listing those records basically. And we are grouping the data. So rather than listing all the records as it is, we are grouping the data. So we are listing who usually takes how many vacation hours and so on. So here, if you look at the sample data, we can easily identify that single male employees, on average, they usually take more vacation hours. So likewise, you can choose to get more types of, or execute various types of queries to meet your business requirement or your reporting requirement and display the data and so on. So basically, SQL or SQL, you can still informally call it, is basically meant for querying your relational databases. And you can also choose to use a slightly more advanced syntax as well. It's called with select. So with select, before I explain the syntax, when exactly we should use with select. So basically when you want to utilize a very complex, or you want to utilize multiple tables and your requirement is to make sure you have a certain operation performed on another table. So you want to perform some operation on a different table. What exactly does that mean? So in advanced cases, we use something called subquery. So a subquery is basically a nested query. So a query within a query. So when you have to write a subquery, although you can choose to write it, it's usually fairly complex to read it. Those guys who are familiar with it, if you're used to it, well and good, you can use with the subquery syntax. Otherwise, you can choose to simplify it somewhat by using this with select keyword. So with select is nothing but just an alternative syntax for using a subquery, sort of a nested query basically. So keeping this in mind, let me show you an example here. First of all, let me show you the sample database that I have on my site before I explain this particular query. Okay, so database-wise, I have this AdventureWorks database. I already have a table. I've named it employee. Let me first of all show you that table. Okay, so it's a very straightforward table. And notice that we have a single table that contains the employee ID. It's unique. We have employee name. Currently, I'm not really storing the employee name. I'm just storing the employee job title or role or something like that, basically, just to keep it a bit simple. So we can see the result and understand it with ease. And we are also specifying who's the manager of what employee, etc., and so on. So as intelligent human beings, we know that the manager of this accounts manager is one. So one is CEO. So CEO is the manager of accounts manager in this particular sample data. So likewise, we have this senior salesperson, one, who's the manager of this person, two is. So two is sales manager. So basically, as intelligent human beings, we can understand this structure. And this is where basically we have self-join sort of relationship. So basically, if you want to find out who is the manager of what employee, etc., and so on, you will end up having self-join sort of relationship here. So if you want to list all the employees and who is the manager of that employee, you have various options available. And one of the very commonly and sort of the better recommended technique is to use this with select option. So with select will let you create a subquery, a nested query. So before I explain the syntax, let me just run it. So we can now see CEO, no one is the manager of CEO. Sales manager, one is the manager of sales manager. Accounts manager, who's the manager of this person, one is. So basically you can see who's the manager of what employee, etc., and so on. And you can definitely choose to take it to the next level by displaying the actual manager name as well. For that, you'll have to use inner join syntax. So for now, I'll just keep it as it is. So basically here we have this subquery. So overall, it is a standalone query. It's a standalone subquery, but it's actually not really a standalone query because it's relying on this outer query as well. So this is the actual query that we want to execute, but it will heavily rely on this nested query. So it's sort of a recursive sort of pattern. It will repeat a certain select statement on every nested sort of query and so on. So the nested query will return multiple employees based on who's the manager of that particular employee, etc., and so on. So definitely due to the lack of time, we cannot go into too much depth of it, but just know that with select is a slightly advanced, but at the same time, a very elegant way of handling subquery sort of concept. Usually this with select syntax is also known as common table expressions. It's very useful when you have to use the nested query concept and you want to make it look more elegant. It should be easier to understand, etc., and so on. So overall, we have two main techniques when we have to query your relational databases. You can choose to use just the select statement, but if you have to use nested query, it will become fairly messy. Or you can use with select to simplify your subqueries or your common table expression sort of syntax and so on. And when you use relational databases, you can create different types of SQL objects, such as views, functions, stored procedures, triggers, and so on. Essentially, all these are saved queries. So you want to write a query once, rather than rewriting the same query over and over again. You just write it once, save it. So in future, you'll be able to reuse that query. And we have various techniques available. So here I'll just give you a quick overview of these techniques. Usually the detailed discussion is available in the full-blown courses that we have. And due to the lack of time, I'll not be able to show you everything end-to-end because we also have to focus on MDX, multidimensional databases, tabular data model, etc. as well. So views, they are the easiest ones to understand and to utilize. So a view is nothing but just a saved query. So if you have multiple tables, you want to get a few columns from this table, a few columns from this table. You want to create a logical view. So logically, these two physical tables should be combined. Not physically, but logically. So you'll end up writing your select statement. You'll use inner join, outer join, etc., stuff like that, and so on. and you will save it as a view. So a view will look like as if it's a physical table, but it's not a physical table. It's just a logical view of your existing tables and so on. The drawback with views is that you cannot use parameters. You cannot parameterize your queries. Like if you want to create a report, and a report has, let's say, a bunch of drop downs or text boxes or radio buttons, etc. and so on, date picker controls and so on, and you want to parameterize your query, views do not support parameterization concept. So in that case, you'll basically have to rely on some other technique, such as functions or stored procedures. Functions are pretty much like views. So they are very much like views. But the added benefit in functions is that you can parameterize them. So it does support parameterization. And the drawback with functions is that you can have just a single result set or a data set returned from that function. It cannot return multiple data sets or result sets at all. You're limited to a single result set. So in the end, you will have to make sure your select statement returns a single output or a single table basically. Or you can choose to return a scalar value as well, just a lump sum value like a minimum of something, maximum of something, etc. and so on. You can choose to return some aggregate value as well if you want. Stored procedures are more advanced. They have lots of benefits. Like you can use any number of statements here. You can use your select statements. You can use insert, update, delete statements. You can perform transactions. So transactions means you can choose to initiate some process, and if something fails, you can undo it. So undo is available here. So for example, if you have, let's say, a checking account sort of table, you have a savings account table, and you want to deposit some balance into your savings account. If let's say the deduction is made, you're able to deduct the balance, it's transferred to your savings account. Or let's say just the savings account is updated, but it's yet to be subtracted from the checking account. So you have to basically make sure you update your savings table as well as your checking table. So if let's say the partial operation was completed, and after that there was some issue, like you lost your network connection or something like that and so on, in that case, you'll want to make sure you undo the transaction. So the undo functionality is available in case of stored procedures. And although you can utilize or create triggers as well, but typically you don't create triggers for the sake of querying your data or for the sake of manipulating your data. Triggers are typically used when you want to intercept some event. Like someone is, let's say, performing some insert operation or whatever other operation, and you want to, let's say, audit it. Auditing wise, you want to make sure you have a custom table, and you want to keep track of what record got deleted, what record got updated or inserted and so on, who did that, what was the date and time, what was the application name, etc. and so on. So that is where you can choose to utilize triggers concept. So you can intercept certain events like insert, update, delete sort of events. In more advanced cases, we can intercept DBA level events as well, or server level events like login operation. So if someone is logging in, even that event can be intercepted as well and so on. So triggers, they have lots of usages, but in short, it's just some lines of code that will be executed whenever some event is triggered. So you want to wait for some event to happen, and then you want to perform some operation. And SQL's or SQL queries, they do offer lots of functions. So basically, we have talked quite a bit about the relational databases. Let's talk about analytical databases as well. Analytical databases, they are also known as online analytical processing databases. So the focus here on the letter A, analytical. So we want to focus on analysis, basically. We want to analyze our data. So that basically means the select operation is optimized in this case. So they are very, very fast compared to your regular OLTP databases. So they are typically pre-processed where your aggregates, your grouping operations, they are pre-performed. Like what's the overall lump sum value for, let's say, your sales amount or et cetera and so on. And you want to break it down by various other factors. So you can see your data breakdown and so on. And whenever we utilize analytical databases, we usually focus on data modeling. I'll talk about that in detail in just a bit on the very next slide. And the main benefit you get with these types of databases, number one, ease of use when it comes to utilizing them. Because these are pre-modeled. So even a layman person who knows just Excel, nothing else at all, just a simple Excel user, so even that person, without writing even a single line of code in any language whatsoever, will be able to connect to this analytical database and perform the breakdown sort of operations and so on and analyze the data. So basically ease of use, pre-modeling, this is one of the major benefits you get with it. And super fast because typically it's pre-processed. And data modeling, it's a huge area. So typically we create dimensions, measures, we focus on schemas such as star schema, snowflake schema, we utilize attribute hierarchies, we use grouping and binning concepts, we create KPIs and so on. So typically what we do is we create a scenario or sort of a database that helps us in answering various questions. So multidimensional databases or analytical databases, they focus on various questions. Like we have some facts, we know that something has happened. What has happened? We have accumulated $1,000 worth of, let's say, cost or something like that and so on. Or we have, let's say, sold 10,000 products. We have 15,000 items in our inventory. So it's a fact, it's there. Now we have to analyze it. We have to break it down by various factors, like who did that, what caused it, where it happened, why it happened, how it happened, when it happened. So typically when we have to analyze our data, we focus on a structure like this. So we should have numeric values in the middle. Usually this table is known as a fact table, or we also call it a measure table or measure group table, and we have dimensions around it. So questions like who, what, where, when, why, how, etc. and so on, these are usually called the dimensions. And in the middle, we have the facts. So this way we can break down our facts by various questions and get to the root of the issue, etc. and so on. And typically when we have this sort of structure, we create something that is known as a cube. So analytical databases, they can be implemented in various ways. A very commonly used technique is to create something called a cube. So a cube will be pre-processed. All your questions, your dimensions basically, and your measures or your facts will basically be pre-processed here. And definitely you'll have to get the data for this cube from your regular data sources such as SQL Server, Oracle, whatever you want, even from CSV files, Excel spreadsheets as well and so on. So usually we create our data warehouse and we populate it and then we create the cubes for it and so on. And then after that, we get to utilize something called slicing and dicing. The slicing and dicing basically means whenever you have to get answers to your questions, you basically break down this giant cube into multiple small cubes. Basically, we get to slice it and then slice it by multiple dimensions. It will become a dice basically. So for example, we have $15,000 worth of sales, let's say. So now you have to ask your questions. What product got sold? What was the year when it got sold? Where it got sold? Who bought it, etc. and so on. So when you have multiple dimensions and you break down your, let's say, $15,000 worth of sales, that's sort of just a case study here. Your fact, even you're breaking down your fact by multiple dimensions or dimensional attributes, you'll basically get the intersection point. You will know exactly what product got sold, what was the year, what region was involved, etc. and so on, when you made the sales and so on. So when you have this sort of structure, you have to first of all create your cube. And it's out of the scope to cover it in detail, but I do have a sample cube here. So basically, we have to use something called analysis services along with a tool called SQL Server Data Tools. We create our views, we create a cube that's composed of multiple measures and multiple dimensions. And each dimension is composed of multiple dimensional attributes. And then we can, let me show you a cube browser as well. So basically, you'll be able to break down your data in Sun. Let's say we break down, like in this case, currently I have these facts. So I have a human resources sort of scenario, like sick leave hours taken by the employees. It makes sense these days because of coronavirus sort of situation. So overall, employees have taken that many number of sick leave hours, 13,000. So what department is taking the vacation hours? Or sorry, the sick leave hours. So here we can see the breakdown by department name. And notice that we are able to just drag and drop and view the breakdown with ease. Those guys who are coming from Excel, it is like a pivot table, but it is connecting to our cube that is eventually connecting to our under the hood sort of databases like SQL Server and Sun. And you can see the breakdown with ease. Let me break it down by, let's say, shift name. So here we can see that day shift employees, they usually have to take more sick leave hours. So likewise, you can choose to see the breakdown by pretty much any factor or any dimensional attribute and so on. Like let's say what age group usually takes the sick leave hours. Here I've already implemented something called grouping and binning. So we can see the age range as well. So in this, let's say day shift, we have employees aged between 35 to 37. They take that many sick leave hours and so on. So able to slice and dice your cube, your facts, your measures, your numeric values basically by multiple dimensions or dimensional attributes and so on. And under the hood, it makes use of a syntax called MDX. I'll give you an overview of MDX in just a bit. But in short, under the hood, it's making use of MDX. And if you recall, I also mentioned that when you create your analytical databases, they are very easy for even any Excel user to connect to. So with ease, I can connect to this particular cube from Excel or from Power BI. If you use Power BI for analysis purpose, you can use that, or you can use Tableau, you can use SQL Server reporting services or report builder. There are so many different options available. So this structure is basically coming from our cube. It's a pre-modeled structure. So the end users will never have to worry about what is the SQL syntax, because usually information workers who use Excel, typically they are not aware of how to write the select statement, etc. and so on. But under the hood, it is making use of MDX language. So first of all, let me show you that the breakdown of our data is available here. I actually have, okay, in this one, I don't have the KPI. For now, let me just break it down by shift name. So basically the same thing that I showed you previously, it's available if you use Excel or even if you use Power BI, etc. and so on. And you can definitely have as many dimensions as you want. It is not a 3D sort of thing in the sense that you need to wear 3D glasses to view it. You can have any number of dimensions. Like even in my case, I actually have dimension number 1 that contains employee personal information, or let me just show you the cube. Go to the cube designer here. So this is basically your fact table, and we have multiple dimensions. So we have dim employee personal information, dim employee work information, dim birth date of the employee, dim department shift information about the employee, dim hire date, etc. and so on. You can have as many as you want. Like sales sort of scenario can be broken down by customer, product, region. You can have as many as you want. So you can have any number of dimensions basically. So that's where we have slicing and dicing basically. And you can connect to it from your Power BI, from Tableau, from Excel, etc., and so on. There are so many different reporting tools available, and you can connect to it from pretty much any reporting tool. And under the hood, it makes use of a couple of scripting or not syntaxes basically. So we have MDX. It stands for multi-dimensional expressions. So let me give you an overview of MDX here. For MDX, I already have my cube deployed to my SQL server. I can quickly create MDX-based query here. So here we have to make sure we use the select statement, but not like we usually have for the relational databases. We always have to focus on two sort of sections. So a section for the facts that you want to break down, and a section for your dimensions. So we want to break down something by something. We always have to use on columns, on rows, and then we have to specify our cube. Our cube name is sales. You can just drag and drop this thing here. And then here we have to specify, let's say, our measure. So we want to break down, let's say, internet revenue. So we want to break down our revenue by various dimensions, like let's say customer. So customer wise, we can, let's say, choose to use as many as we want. Let's use city for now. And usually when you just run it like this, it will just show you a lump sum value like this. That doesn't make too much sense. Ideally, it should show us the city as, or all the cities as well. So that is where we usually have to use some additional keywords that are available as part of MDX, like we have children, we have all members, etc. and so on. So we have lots of cities, but not every city had some sale. So here, you can choose to use non-empty if you want to get just those records where the value is not empty, or we have to do it for the measure as well separately. But we have various keywords available, so you can filter out the data and so on. So basically, in this case, you can see that the syntax is somewhat different compared to your regular SQL sort of statement. You can use various keywords like, let me actually show you this particular query here. It does have somewhat weird syntax. And let me first of all make sure it's the right database. So yes, so here we are looking at the prices or the cost of various products. And we are also breaking it down by state or province name. So we are viewing the data just for Texas here. So we have where class involved as well. We're able to display or utilize multiple dimensions. So all the dimensions typically go on that rows slicer. So these are also usually called the slicers, or sort of the axis where you want to display these or plot these. So we are able to see the breakdown. So currently I'm just using this SQL Server Management Studio, which is not a proper reporting tool, but still you can write your queries, see the output before you start using them from any other reporting tool and so on. So you're able to see the breakdown. Let's say if you see the breakdown for Ontario, we have just accessories sold in Ontario. We have the city name as well. Likewise, if we have, let's say, Alberta or some other province here and so on, we can see that we had some sales just in Calgary, etc. and so on. So basically, this syntax overall is known as MDX syntax. And there are lots of functions, lots of keywords involved, definitely. But here, the main scope of this session is not to discuss everything end to end. Because of the lack of time, we cannot do that. The main focus is just to understand when to use what syntax and so on. So with analytical databases, we can use this MDX syntax, or we can also use something called DAX, data analysis expression. So question is, why do we have so many different syntaxes for analytical databases? So analytical databases can be queried both with MDX as well as DAX. A bit of history of these two languages is that back in SQL Server 2005, Microsoft introduced cube concept. Initially, Microsoft made just one language available, and that was called MDX. MDX exists even these days as well. But pretty much nothing has changed in the latest version of SQL Server since SQL Server 2005. So everything has stayed pretty much the same, basically. In SQL Server 2012, Microsoft ended up introducing another syntax called DAX. And DAX is available these days, definitely. And this is the main focus of Microsoft these days. Like Microsoft is definitely prioritizing DAX and adding more functionalities to it and so on. And even modeling wise, Microsoft has simplified the modeling technique somewhat. Like this technique, the cube-based technique that I showed you previously, some people might find it a bit advanced. If you're used to it, well and good, you'll definitely find it a piece of cake. But if someone is new to it, will find it a bit challenging in the beginning. Like there are lots of things involved here. Like in more advanced cases, it also lets you utilize mining structures that lets you utilize data mining or predictive analysis. You can get various interesting facts about your data, like it can profile your data and give you some recommendations or suggestions, like based on your existing data, this is the pattern, etc. and so on. So this can be a fairly advanced tool to model your data. Whereas the easier version of it was introduced in 2012, and that is called tabular data model. So tabular data model is much simpler. It lets you create or import your data from various data sources such as SQL, Oracle, CSV files, Excel spreadsheets, and so on. They will all show up as tables here. And you can model these. You can create the relationship between these, make sure that it matches your reporting requirement. And then once you have deployed it, you can start querying it by using DAX, or you can still use MDX as well. So DAX, data analysis expression, is a newer way of querying your analytical databases. You can still use MDX with both these types of databases, or sorry, with your analytical databases, or you can use DAX. So let me give you an overview of what a typical DAX syntax looks like. Let me go back to my SQL Server here. And I can use the same cube and use the DAX syntax. DAX has lots of keywords. Here we'll definitely just focus on one of the commonly utilized syntaxes. Evaluate is sort of a keyword or sort of a function as well. Filter is equivalent to where clause. We have order by, we have techniques for grouping data as well, and so on. So basically, it's pretty much the same scenario that I showed you previously. And we are able to see the data or the sales or the customers basically that are located in a certain province. So here we are listing all the customers that are available or located in Alberta. We are displaying the city information, the last name of the customer, etc. and so on. So this syntax is known as DAX-based syntax. And you can utilize it from any reporting tool, such as from Power BI, or from any other reporting tool such as Tableau, etc. and so on. Let me just briefly show you how it will look like if you use Power BI. So here I have this Power BI. Let me quickly start off with a blank report here. So I'll just take a minute or so to just quickly wind it up. So basically DAX is the modern syntax. It's newer than MDX. MDX still exists, but DAX is, some people find it easy actually, or actually quite a few people find it easier compared to MDX and DAX because it's very much like Excel sort of functions. So if I, let's say, quickly connect to my analysis services and just place in the query here. That's my server name, and my database name in this case is, let me just quickly double check, AdventureWorks OLAP. And here we can choose to type in our query. So notice that we can type in our MDX or DAX query. So if you type in a query, it will retrieve just these columns or just these records into a reporting tool and so on. So basically, DAX, typically it's an easier syntax compared to MDX, but both MDX and DAX, they are meant for querying your analytical databases that are optimized for performing your select operation. Okay, so basically here we have discussed various options, like what types of databases we have and so on, and when to use what language or what syntax and so on. We do have various courses available, like if your focus is on relational databases, you want to use SQL queries. For that, we have this 20761. Whereas if your focus is on creating your analytical databases, you want to focus on creating a data model that should be accessible from any reporting tool. For that, we have this 20768. It's meant for creating your data models or your analytical databases, and it focuses on MDX and DAX sort of queries and so on. Okay, so definitely the slides as well as the video session will be recorded to our website. You'll be able to access it. So thank you very much, guys. It was a pleasure to be here with you for this session.